In this video, we review linear equations in one variable. We're going to start maybe with some examples of linear equations. Okay, here's one. Okay, here's another one. Sometimes you could have like expressions that potentially can be expanded on one side or both sides of the equality. This is one that you'll recognize from maybe the previous video. The difference between this one and the previous two is that here you have two variables. You've got x and y. Okay, so I'd be able actually to sketch the graph of this equation in the Cartesian plane. Here's another one. The last two are actually two popular ways of writing the equation of a line, so we're going to review those. Sometimes another popular way, which is equivalent to the one just above, is just having the y minus a constant on the left hand side. And what makes them linear is that on both sides of the equality symbol you've got polynomials of degree 1. Okay, that means that the highest power of x or y that you find there is 1. So you cannot have something like x squared, and you cannot have, so here are the things you cannot have. You can't have an x squared somewhere, you can't have a y squared somewhere, you can't have them being multiplied together somewhere, and then you can't have fractional exponents, square roots, 1 over x. Okay, so all of that is forbidden. So it's really, on both sides, after expanding, you should end up with an equation of the form, okay, this is as general as it can get, I guess, after expanding. Yeah, you can't write my letters and like that. Okay, so after expanding, that's the most general linear equation you can get. Okay, so you could have on both sides polynomials of degree 1 in one variable. Okay, so by the way, again, it's not possible to have something like x times y times some coefficient. Okay, that would not be allowed. So two important types of types, okay, of linear equations, especially the you've got the slope-intercept form. So what is that? Okay, so this is the equation of a line you can get when you've given the slope m and you're given the y-intercept. Let's call it 0b. So 0b is the y-intercept. So of course the first coordinate is always 0, right? Because it lies on the x-axis, so x is 0 there, and b is some number. Okay, and this line would, let's say, be is positive, would be here. So 0b would be the y-intercept. If m, let's say, is positive, it would be an increasing line like this. So for a step of 1, you go up by m. This form, when you're given, let's say, the slope, let's say an example here. Let's say you're given m is 2, and you're given 0.3 for the y-intercept. Okay, you can immediately write down the equation of the line. It's going to be y equals 2 times, well, the x, so the slope times x plus the y-coordinate of the y-intercept. And you can check, right, what multiplies x is the slope, and the constant term should be the y-coordinate of the y-intercept. So in general, you're going to end up with something like y equals mx plus b. So this is slope-intercept form. So if you're given the slope and a point, okay, that's it. You can, the slope and the y-intercept, you can immediately write down the equation of the line. But sometimes we're not given, we don't know what the y-intercept is, or we're not given that information immediately. Sometimes we're just given a point, okay? So for that reason, we've got an equation for the line that can be easily derived. That's called the point slope form. So here you've got m is the slope again, and now you're given AB. So it's not the same b as before, right? Now it's just AB, some arbitrary point is a point on the line. So in calculus in particular, we get those type of information a lot, and then we want to write down the equation of the line. So maybe if I sketch it, right? So you've got a point. Let's say this is AB, and then m means if you go forward by 1, you go up by m. Okay. And then you end up with some line. All right. Now imagine that maybe not this one. Maybe let's read. I'm going to sketch it just next to it, so next to the graph, so that you can see what's going on. So let's say I've got some point xy that lies on my line. Well, one thing that's constant about a line is the fact that its slope isn't changing, right? So if you go forward by 1, you go up by m. If you go forward by delta x, okay, so you're not taking a step of 1 now, taking a step of x. Well, how much you go up also gets multiplied by x. So m gets multiplied by x. So in other words, your delta y, the amount by which you increase, is m delta x. And that means that m is always going to be equal to delta y over delta x. So if I look at delta y over delta x using these 2 points, okay, well, delta y would be y minus, so y here being this, minus the y coordinate of this other point, over x minus the x coordinate of AB. And that's constant. So that means that y minus b, if I solve for y minus b, that's going to be equal to m times x minus a. And that's the point slope form. Okay, so this is the point slope form. So if you're given, so as an example, you're given a line with a slope of -3, and it passes through 3 minus 7. Now 3 minus 7 is not the y-intercept, clearly, right? So you're just given a point, some arbitrary point on the line and a slope. Using that formula now, I can just write that y minus the y coordinate of the point is the slope times x minus the x coordinate of that point. And that's an equation. Usually if you've got like 2 minus signs like I do in the first expression on the left hand side of the equality symbol, you're going to replace the minus minus with a plus. So this could be the equation of our line. There are many ways we can write it down. We can send the 7 on the other side like that. This is equivalent. We can expand it, and then if I expand it, I'm going to be writing it in the form mx plus b. So I'll show you. If I expand it, now it's in slope-intercept form. So the y-intercept I can see is 0, 2. This is this and this. Not this, no, not the last one. This, and the one above. Those are all equations. Those are all equations that correspond to the slope, point slope form. Point slope form. So if you take the point slope form and you expand, solve for y, you're gonna get the slope intercept form. So but if you're just asked for the equation of a line, depending on the information you're given, you're gonna use either the point intercept form or the slope intercept form. And if you're just asked for the equation of a line, there's no need to do those extra steps here. You could just stop with what I framed as your answer. Okay, so here's another example. Here we're going to graph y equals 2x minus 1 minus 1. So that equation, I can recognize that it's in point slope form. You see it's of the form y equals a slope. So what ultimately, if I expand it, what's going to multiply x is that 2. So that's going to be my m for sure. So m, x minus a plus some b. So I can see that m here is 2 and a point on this line is ab, which is 1 minus 1. So if I want to graph this, this is what I could do. There are different ways of graphing this. I could, but let's say I use the information I just found. So AB, which is 1 minus 1, right there, is a point on this line, and the slope is 2. So if I go forward by 1, I go up by 2. So I'm going to end up here. Go forward by 1, the x coordinate changes to 1, go up by 2, it's 2, 1. I could check that this is correct by replacing x by 2 above. So if I replace x by 2, I get 2 times 2 minus 1, so 2 times 1, which is 2 minus 1, 1. Yeah, it works. 2, 1 is a point on this line. Okay. So that's one way. What else could I do? I could actually find the x and y intercept of that line and get those 2 points. And you see, if I want to get for example, the y intercept, there are 2 ways. Either I could just expand this equation. So let's say here I'm looking for the y intercept. What is it? Well, I could just expand this, and I see that minus 3 is the y coordinate of my y-intercept. Or what I could have also done is say, well, actually the y-intercept is going to occur when x is 0. Right? So, and minus 3 is the y coordinate of the y-intercept. Okay, so this would be like solution 1. This could be solution 2. Okay, they're both valid. And what's my x-intercept? Let's say I'm asked to find the x-intercept. This is when y is 0. Okay, so I make y equal to 0, solve for x. 3 is 2x, so 3/2 is x. So 3/2, yeah, that makes sense, right? Because this is 1 minus 1, and I can see the x-intercept is just between 1 and 2. 3/2 makes a lot of sense. 3/2 0 is the x-intercept. Okay, so I don't need all these informations to graph the curve. Usually, however, when you graph a line, it's a good practice to indicate the x and the y-intercept. And I'll end up with one last example. Here I want to find the equation of a line passing through 2 points. Okay, and maybe I'll show you 2 solutions. So the points are 3, 4, and 1 minus 3. So one thing I can do here is calculate the slope. So slope is going to be delta y over delta x. So maybe minus 3 minus 4 over 1 minus 3. So that's minus 7 over minus 2. And after simplifying, 7/2. So this is a line that's going to go up, right? Positive slope. And so I've got the slope, and I actually have 2 points. So I need more. I have more than I need. I can actually write down the equation of a line if I have a slope and a point, right? And remember, point slope form. So what I can do is use one of those 2 points to write down the equation of the line. Let's say I use the first one, y minus the y coordinate of the point, which is 4, is equal to the slope times x minus the x coordinate of the point. So this is using point slope form and using the first point here. But I could also use the second point, okay? So I'm going to show you maybe another possible answer. So 1 minus minus 3, so careful, that's going to become plus 3, equals 7/2 x minus 1. And you may say, well, those look actually quite different, but they're not. If you, let's say you solve for y, both of them, you're going to end up with this exact same thing. Okay. I can show you that this, well, I want to show you that this is true. Well, you can do it yourself. Like if solve both for y, you're going to end up with the same expression. And it's after solving for y and regrouping like terms, it's going to end up being in the form mx plus b. So you're going to end up with the slope-intercept form, which is actually my solution number 2. This is a solution I see a lot students doing, and I wanted to show it to you to show you that it's actually more work. So it starts the same way. You calculate your m. Okay, so this you can't avoid. And after that, the students will say, oh, actually, okay, it's going to be mx plus b, and what they'll do is they'll replace the m by 7/2. Okay, that's fine. But then to find their b, they're going to use a point. Let's say if they use 3, 4, they're going to replace y by 4 and x by 3 in order to solve for b. So they would get here with 4 minus 20/1/2 is equal to b, and 4 is 8, 8/2. So that's 8/2 minus 21/2, which is minus 13/2. That's b. Oh, finally, they end up with their equation. So y is mx plus b. Okay. But if you just look at the 2 columns, you can see that solution 1 is way faster. Actually, solution 1 requires only this, really. Okay, I gave you another possibility. That's why it's a bit longer. But 2 lines are necessary, where here I need 1, 2, 3, 4, 5, 6 lines. Okay, so this is not the best method. Okay, it's more work. There's more chance of me making a mistake. Actually, I checked my what I wrote down my course notes, and I had made a mistake. You see, so there's a chance of making a mistake because you need to calculate that b.